Good morning, everyone. Thanks for joining us today. We're really excited to have you here. We hope 2025 is off to a good start. My name is Melissa Spohr. I'm a customer success manager here at Lean Techniques. If you're unfamiliar with Lean Techniques, we are a technology and management consultant company based in Des Moines, Iowa, with a distributive team across the United States. We help organizations turn technology into a competitive advantage by equipping leaders and teams with confidence and skills they need to excel in 5 areas: software engineering, cloud, AI, digital products, and strategy and leadership development. We're also an AWS Advanced Tier partner, which enables us to help provide our customers with greater technical expertise and maximize cost savings. Today, I'm excited to introduce 4 team members who have attended re:Invent in December and are doing the hard work of distilling what they believe to be the most important AWS announcements that will have significant business upside. Serving as our guides today, we have Tim Gifford, Josh Angolano, Daniel Ward, and Mike Clancy. Before I hand it off to them, just a final note, feel free to use the chat to ask any questions as we go along. We'll do our best to address as many as we can throughout or save time at the end. And now I'll turn it over to Tim Gifford to get us started.
Awesome. Well, thank you, Melissa. The first thing we're going to talk about is data analytics. I am Tim Gifford, although I have a bit of a beard today, so hopefully that's not too distracting. I want to tell a little bit of story about Aurora serverless. Kind of as we're talking about data, I'm going to start kind of at this data storage level. This is an operational data store. Part of the benefit of the cloud has been this elasticity that you get with it. But one of the things that's been missing is this ability to scale to zero, specifically around Aurora. So I'm really grateful and happy that they've added this feature. So what this allows you to do is, instead of having to pay the cost of running a database server 24/7, you're allowed to scale to zero when there's no usage on that server. So this allows you to have maybe a little more similar environments from your dev to your prod. But I do have a couple recommendations if you're going to use this capability. Is make sure, because this as it scales down and scales back up, it can take up to 15 seconds to restart. So make sure you're setting your client timeouts to greater than 15 seconds. And I'd also recommend you put some sort of retry logic in there. Most of the other things that I'm going to be talking about are not related to these operational databases. It's really around the database, the stories around analytics tools. And in order to start that story, I want to talk a little bit about an extremely brief overview of some of the architectures in data analytics. The first one is the data warehouse. So we have our operational data store. The first thing we do is we get that data moved over into a data warehouse. These were kind of the first things that company tried. They create read optimized database structures so that you could run your reports off those very quickly. It moved the load away from your operational data store so it wouldn't impact your asset transactions. And this was great until we got to a point where we ran out of memory. Our data sizes were so large that we couldn't do that. So we started moving into other data storage mechanisms. The next one that I really kind of gained some popularity was data lakes. And ultimately, this was just where you put all your raw data. A lot of times this architecture involved using Amazon S3. You just create a bucket or buckets and put all your raw data in there. Because there was a delay between the time that we got the raw data and when we could actually get the data engineers to transform it and get it into the table structures of our data warehouse. And then finally, this new evolution that's happening is everybody's talking about lake houses, and it kind of sits in between the two. And the big innovation that's happening here is, instead of using these Parquet files back for the data lake days, we're building on top of the Parquet files. Parquet does a great job of just storing the data in a very optimized way. It's starting to put table metadata on top of it. So this is where it's not only taking your Parquet raw data, but now you're able to put metadata and describe the columns and the structure of your tables. This has a couple interesting characteristics. Because you have the table metadata, you can now insert and update and run SQL against these basically files that are running in S3. The challenge is they create snapshots, copies of your data every time it makes a change to that data. Now, these snapshots are really powerful because it allows us to create, be able to do time travel. We can go forward, we can't go forward in time, but we can look back in time to see how our data has changed over time. And it allows us to manage schema evolution. And what I mean by that is when you add or remove columns from your database. So with all of that, the challenge that we've always had with running Apache Iceberg on these S3 buckets is query performance of S3 isn't that great. You get 5,500 requests per second. You get all of these snapshot files that start to get overrun in your S3 bucket, and you've got to create compute time to actually compress and manage how you're going to remove some of these unreferenced files. And then security has always been a problem because it's file-based security. You're managing where your S3 buckets are and who's got access to whatever. And so at reInvent, Amazon introduced the S3 table bucket. This is a way to address those challenges. They've created some optimization around query performance, a 10x optimization for Iceberg tables in an S3 table bucket. They've created some automation and made it a managed service to manage all of the storage computes that you need to do, the compression, the repartitioning, and all of those pieces are now handled for you. It's created a catalog. It registers it with a catalog, so you can do fine grain permission. And what I mean by that is you can give people access to tables or columns. And so you don't have to kind of manage that at the file level. And then it's all integrated into their overall analytics platform. So they make it a lot easier using these S3 table buckets, using these icebergs. And building on top of that, they have this thing called the SageMaker Lakehouse. And this is where they've layered on top of this to make it more accessible. And it's all integrated into their unified studio that we'll talk about in a moment. Because we're using Apache Iceberg, it's an open source format. So you can use any tool that can read and query Apache Iceberg. And this whole unified platform allows you to do this, use the Apache Iceberg API to get access to your data. It creates a unified governance layer so that you're all getting all of your data is managed in one place. You can pull in data in the data lake from both your S3 locations or your Amazon Redshift managed storage, which can be, so you can do queries now between Amazon Redshift and these Apache Iceberg tables together. So SageMaker Lakehouse makes it much easier to organize and secure your data wherever it's stored. But now we're going to look at some of the problems or some of the things that how do we get the data into that lakehouse? And so I'm going to do another extremely brief overview of data replication. Getting data into the lakehouse has been pretty easy with inserts. Anytime we have inserts, we just can append to the table. We don't have to worry about conflicts or anything like that. We're just adding new rows. Very easy problem to solve to get data moved over. Updates a little more difficult. We've got some technology called upserts that checks to see where the data is, and it will overwrite existing data instead of updating with a new record so that we don't get duplicate rows. But then we get into some tricky problems. Deletes are hard to find. We don't know in applications or in tables where deletes happen. There's no way to do timestamp tokens on deletes because they didn't exist or they don't exist anymore. So if we query to find out when they did it, it's kind of a hard problem to get around. APIs, applications, they don't have any standards around this. But with Iceberg time travel, we now can compare what was there versus what is there. And now it's a little easier to be able to compare the difference to track deletes. The other thing we get with Iceberg, with this new technology of Iceberg, is the ability to see when columns are moving around or changing for schema updates. This is a really complex problem to solve when you're doing traditional ETL, extract, transform, and load routines. Apache Iceberg, because of these snapshots and being able to time travel, you have a better you can more easily track when these changes are occurring. And because of that capability, AWS has released a few managed services specifically around what they're calling, it's kind of this zero ETL initiative. And so I don't know if anybody's had experience with ETL pipelines. They get really complex. They tend to take a while. The time to move the data from one space to the next space can be daunting, be error prone. And so they've had data source zero ETL from their Aurora and their from Dynamo in the past. And now they've added it for some SaaS applications. So Salesforce now has a zero ETL to get all of your Salesforce data directly into that lakehouse. My opinion is that with these, what do we have, 8 right now? I believe that those are going to continue to grow, which will make integrating from those transactional applications that a lot of us use, make it a lot easier to get that data into your lakehouse so you can start to query on it. Finally, what we'll do is we'll take a look at Amazon SageMaker Unified Studio. This app is cool. It's a great user interface. I played with it a little bit. It integrates all the different stakeholders for all the different stages of your data lifecycle. So your data engineers, your data wranglers, whatever you call them, your data analytics folks, they're all playing in the same sandbox. And inside of SageMaker Studio, it's that one pane of glass. It has unified governance. You can create shared projects for different people. Within those projects, you can configure the compute so every person that's working with the data can have shared compute resources that can be set up once and managed in one place. So you can share Git resources together, data assets, project templates. There's just a lot of advantages to having the single pane of glass. You don't have a bunch of different places to go anymore. And this is currently in preview and was shared at AWS reInvent back in December. I do have a focus on it being free. Now, of course, this is a free tool, but any of the services that you use behind on the background, you do have to pay for, but at least they give you a really great interface to get all the people on your data team that can work together. Thanks for letting me share a few things I think are pretty exciting about the data analytics space. I'm now going to hand it over to Daniel to talk about developer productivity.
All right. How's it going? I am indeed Daniel Ward. Developer productivity, I'm going to sort of define as any new service or tool or thing that makes developers what they're already doing, it lets them do it faster or less painfully. So a little broad, but kind of anything in that area. So, quick overview, everything I'm going to go over, it's only 5 things. Here they are. So not very many things, but it's still going to be a lot to cram in this little time frame. And if you're like, Daniel, this stuff is cool, I just can't listen to you. I'm sorry. At the end of every section, I'm going to have a little star and say, here's the business application for this thing. So if you just can't listen to me, just look for the star at the end on each slide. So the first one is EKS hybrid nodes. If we're using Kubernetes, this now lets you use both on-prem and AWS nodes in the same EKS cluster. So even if they're not on AWS, the management doesn't change. You still manage the non-AWS nodes. AWS manages their nodes. And you need to give it subnets in your VPC for the traffic to be routed through to the non-AWS nodes. So this is nice because it standardizes your Kubernetes management, right? If you, whatever different infrastructures you had off AWS, you would need different configuration and tooling for those, and now you can just do it all through the same EKS cluster. And the hybrid nodes don't care what infrastructure they're on. On the reInvent panel, they kind of said, you can put this on a Raspberry Pi or vSphere or whatever. Doesn't care. And because it's going into the same AWS cluster, kind of along for the ride for free, you just get all the things that natively integrate with AWS, like monitoring and logging, management with IAM if you want to do that kind of stuff. So just as a note, if you are familiar with EKS Anywhere, this is not the same. Anywhere doesn't require an internet connection. You install it on your device, and Anywhere's purpose is just to give you like a unified management experience, but it's not necessarily the same cluster. And Anywhere is still better suited for limited connectivity environments. You might not have an internet connection or it might be intermittent. You might be in the middle of nowhere, stuff like that, right? So here's the star. Business application for this is modernization and transformations, right? If you have stuff on-prem or just off AWS somewhere, maybe you have plans to bring it into AWS someday. This makes it a little less painful. You can at least get the cluster management already on AWS, get it talking, and maybe you don't want to move it off-prem or you have no plans to move it into AWS someday. This still makes it a little bit easier because you just get the screen management all in one place. And again, you get stuff like monitoring, logging, the AWS stuff. You just get it for free along with the ride. And I'm not going to go through every little thing on this interface, but here's the console experience here. This is not mostly new stuff. This is when you're creating a new cluster. But you can see important thing is we're passing in the subnets for the VPC. This is where the traffic is going to be routed through to reach your on-prem stuff. And then this toggle down here for specifying the CIDR blocks is new. If you toggle that, it'll ask for CIDR blocks for your non-AWS stuff. So you have to get this from your networking team or whoever that's applicable for. This one is maybe the one I think is the coolest thing. Storage browser for S3. So this is just a web component. It's an open source web component, and it lets you do CRUD operations on S3 data easily. So you don't just have to provide full access, right? You can limit stuff. You can say, I'm going to only let you look at these buckets or these folders. I'm only going to let you read. I'm going to do everything but delete, whatever. You can actually hook it up to whatever auth provider you're already using. Maybe you're using Cognito or Auth0, whatever. You can control the access to S3 this way with those things you already have. And because out of the box, it doesn't look bad, but it's a pretty plain, basic design. So you can customize that to match your own branding. And just for free, along with the ride, you get optimized requests for high throughput. So the star, the business application for this, is you reduce the time to get the feature to the customer, right? It's a very common use case for both internal and external customers. You have some data in S3, some files. You want end users to be able to access those files in some way. Maybe you create new ones, but obviously you don't want to just give them access to your AWS account. So you have to put something in the middle. Well, with this, you don't need anything in the middle, right? You just use the storage browser component and IAM role something to restrict access somehow, and you're good to go. So you can get rid of those custom tooling, custom code, whatever you're doing, and just directly use the storage browser component, right? So easy to imagine how even for internal stuff like your sales or marketing team, maybe they have reports, maybe you're storing those in S3 and they need to manage that stuff. Well, now you don't really need to go through all this work to stand up like this custom website and stuff. Toss this component in there, customize it a little, make sure the permissions are good and you're good to go. So again, not going to go through every little thing in this file, but you can see we're importing this create storage browser from AWS here, this method. This is what creates the component. You give it some things like your region and account ID. You have to give it a credentials provider method for whatever credentials provider that you are using. And you use it just like any other component. This is React. So, we're just creating a storage browser. And again, you can apply styling to this if you want. Here's how it looks out of the box. So doesn't look bad, just a little plain. And you can see we got stuff like add folder, add files, and upload. And the second screenshot here has a little more styling, but I just wanted to show you are literally just seeing what's in S3. These are the folders in the bucket. So if you want to restrict what they can see, you can do that. If you want to let them delete whatever they want, you can do that too. But it's literally just to pass through as much as you want to S3. So pretty cool. Something a little minor, but still nice. There is something out there called Construct Hub now at constructs.dev. And this is just a registry of free and open source construct libraries for AWS CDK, but also CDK A8s and CDK Terraform. So the business application for this, obviously, right, is less time spent rolling your own stuff. You have a bunch of infrastructure solutions, things you need to get done. A lot of the stuff, honestly, is reinventing the wheel a lot of times. So if someone else out there has already done that, there's kind of a central place to go look for those things now. And this is just a screenshot of the homepage. see kind of the bottom here, we can say, I want monitoring solutions or database infrastructure stuff, and I want it for TypeScript or whatever your case is. Declarative policies. This is a new thing. They're just JSON files, and they are for centrally enforcing a configuration of a specific service across your account or organization. So they are not the same as SCPs and RCPs. Those actually restrict which APIs people can call based on the users or roles for SCPs or the resources for RCPs. Declarative policies are for saying, here's the default configuration for this service for everything, and you can't change it, right? And not only that, you can actually have customizable error messages now. And I think the SCPs and RCPs just give you a 401 without telling you anything else. And there's this little page, you can get an account status report now. It says, hey, these are the accounts not in line with the declarative policy. You need to go and change these things. Currently, they only support VPCs, EC2s, and EBS. So it'd be cool to see more stuff from that in the future. But this is the what we're getting out of the box here. So this application for this, I think the custom error messages is kind of a big deal, actually, in big organizations. And because AWS is a big thing, it's kind of hard to figure out a lot as a developer. You might not know ahead of time, like what you're allowed to use, and then you try to use something and you just get denied. And you might not know why. You can say, fine, just tell me what I'm allowed to use. And it's hard to find that stuff sometimes. So with the customizable error message, if they try to do something not in line with policy, you can do something like, hey, here's a link to like our Confluence docs or something with the reasoning why you're not allowed to do this. Here's what you're supposed to use instead. Here's our guidelines for this. And for the people who are actually making these, it's less time managing the org stuff, right? Because you could do it all in one place and it applies to everything. So this is just an example of one for VPCs. We're saying block, you have to have block ingress, and exclusions allowed has to be enabled. So kind of a funky looking JSON format here, but not really too complicated. And this is the account status report. So to give you an idea, this is every single attribute currently supported by this. So it's only 6 across all those services. But you can see a few of these are not in line, and it's telling there's one account in each of these examples that are not in line. So maybe this person has just started setting up policies and it's telling, hey, it's not uniform yet. Some new Amazon Q developer stuff. Some new transformational capabilities for .NET mainframe and VM workloads in a web experience. That's a lot. So in a web experience just means you're doing it through the console. So for .NET framework, they said the example they gave is if you're on the old .NET framework running on Windows and you're moving now, you can use this to move to .NET and put it on Linux to save costs and get all the benefits of a more modern version, security, performance. For mainframe, the modernizing type workload so it can convert COBOL to Java. And in their example, they had this large monolith and they kind of chopped it up into loosely coupled different business domains. And you can convert VMware to move that network onto AWS with whatever different services it needs. Yep. So definitely not going to go through everything in this, but this is just an example of what you might see. So on the left side, you can see the steps that Q has decided it needs to take to do this whole transformation. On the right side, you can see some of the status stuff. So, you know, it says, hey, I need to discover the on-prem data. I'll generate some groupings for it and going to do some VPC configuration, things like that. For the Q developer agent, there's some new stuff too. There's 3 new commands, /doc, /review, and /test, respectively, to generate docs, detect and resolve code issues, and generate unit tests. So examples for that, here's the first one, /doc. So you can see it's just like a VS Code add-on. And then they type /doc and it says, okay, I'm creating a README. And then it does some stuff. And you can see here, there was no README before. And this is all new from Q by looking at your project. So that's pretty cool. This is the second one. This is /code. So it's saying, okay, I'm reviewing your project for code issues. And then I found one critical, one high, and whatever else. And here's the example over on the right side. It says, here's my suggested fix. And slash test on the right side here, it generated a unit test. So business application for this, it generates stuff for you, helps you figure out some of the workload. You spend less time on it yourself on all these things. For specifically the code stuff, hopefully that will lead you to less defects, right? And a more readable code base. This special Daniel Says segment, Daniel says, please, whatever AI in anything generates for you, don't just check it in. Please double check the results it gives you to see if it is correct. AI should be a starting point, not the end result. So definitely useful for getting off the ground, but it is not a human. So as a bonus, I didn't have much to talk about with this because it's not a new service. But Lambda Snap Start is now available also for .NET and Python Lambdas. Snap Start just reduces cold start times. So if you're using .NET or Python, that might be applicable to you. And now I am going to kick it over to Mike Clancy for observability.
Thanks, Daniel. So I'm going to talk a bit about the observability space and what is new, particularly in CloudWatch, which is everybody's favorite observability service. And before I kind of jump into what's new and how it might have some business impact, when you think of an incident that might happen in your application or poor performance, there's kind of three phases you go through. There's the detection phase where you might have CloudWatch alarms notifying you that there's errors being thrown from an API. Then you have the investigation phase where your developers are looking through all the available information in the AWS account to try to figure out what's going on. And then you have that remediation phase where you're actually implementing a fix. Most of the tools that I'm going to focus on are going to help with that investigation phase, which can often take a lot of time and be pretty stressful. And so the features I'm going to focus on were really a feature set. The first one is going to be the ability to transform your log structure at ingestion time and then to query those logs. So these are two features that kind of go hand in hand. And then the next piece I want to talk about is a new tool in CloudWatch called operational investigations. And so this is going to leverage an AI agent to help you determine the cause of poor performance or an incident or an error in your applications. And it's also a great way to document those incidents and some of the data pieces that might be relevant to that. And so when it comes to like the business impact of these new tools, really, it should hopefully reduce the investigation time needed when you have an incident and also give you some insights into maybe gaps in AWS best practices. So let's start with the transform and query logs. This is a screen from a CloudWatch log group. And in the bottom right, you can see a couple new options here. There's the ability to configure field indexes, which I'll briefly touch on, but also the ability to configure a transformer. And so I'm going to look at that first. And so if you think about your CloudWatch, your application and your CloudWatch log groups, you have log groups coming from all over the place. You might have VPC flow logs, you might have API logs or Lambda logs or kind of custom logs coming from your servers. All of these are going to have different formats. And if your ultimate goal is to be able to quickly find information in those logs, one thing you need to do is be able to normalize those logs across all your different log groups. And this is where these transformers can help you. And they happen at ingestion time, so before your logs actually enter your log stream. And there's a couple out-of-the-box options in your transformer dropdown, but you can also create custom ones. So I'm going to show you a quick example of a custom transformer. So I'm using the parser Grok, and there's a lot of documentation out there on kind of how you can write the matching patterns. But imagine we have a raw log coming in here. It's just a timestamp, a client IP address, and a status code. It's just a character or a string of characters. And that's something that's not going to be easy to query if you want to use some of the advanced querying features we're going to talk about here in a minute. But with this transformer, the output is actually going to be this nice JSON object. And so now you've got your timestamp, your client IP, and your response status. And why that's really powerful is if you start blending that with indexes, you can actually put an index on those fields. So they can be queried by log insights, excuse me. And so we've got these indexes being added. And when you kind of put this all together, you've got all your log groups coming in. They're unstructured. You apply transformers, and you're able to assert sort of like some patterns across all those. So you have normalized logs. And then you can enforce index policies on those logs. And now a new feature in CloudWatch Insights is the ability to actually search your logs across multiple log groups using SQL. And so that becomes a pretty powerful tool when we're talking about saving time, trying to identify errors. You know, rather than having to dig through multiple different log groups to try to pin down an error, you can now use SQL to search across all your indexed logs to find those issues right away. And so that's a pretty powerful tool. The next thing I want to talk about is under the AI operations tab in CloudWatch, it's the investigations tool. And this takes a little bit of configuration to be able to use, but they have a link to those configuration steps right under that AI operations tab. But once you get it configured, you will notice that on your metrics screens in CloudWatch and your alarms, there's now this option to investigate. And so I was playing around with this last week, and I have kind of a small sample application. It's just a couple lambdas and a step function, a little bit of database interaction and an API endpoint. But I picked a metric here. I created an error. I deleted a API access key from one of the lambdas and triggered some errors. So this blue line represents a couple errors. And so if you were to imagine this is like a production application or some kind of microservice, you've got that error and you want to figure out what's going on. You can launch an investigation from that metric, and that's going to take you to the investigation interface. And I've got a pre-recorded kind of demo of what that looks like here that I'll talk you through. So once you launch that investigation, you're taken to this screen, and you've got a feed, which if you've used tools like ChatGPT or any kind of AI tool at this point, it's going to be kind of your conversation history. And it starts out with this metric. And on the right, we have suggestions that are coming in from our AI agent of other data points that might be relevant to the issue you're seeing. And you can look at these. And so this one is a state machine, a step function is throwing errors. And as a developer, I know that this lambda is part of that. So I'm going to accept that suggestion. And that now becomes part of our investigation feed. But some of the suggestions are not going to be relevant. So here we've got an API gateway 500 errors. It's not showing any. I don't think it's very relevant, so I can discard that and ignore it. And as this is going on, there may come a point where I kind of have maybe a hunch of what's going on. And so I can actually add my own notes into the conversation to start steering the agent. So I'm saying here, okay, this might be related to our state machine. Let's check the logs. And so I'm able to document that. My teammates are able to come in as well, add their things. So it becomes kind of this area where you can document your investigation. You can collect relevant data points. And eventually here, with the metrics that I've selected and my additional notes, our agent has come up with a hypothesis on the right. And it's actually correct. So it's pretty small text there, but I'll let you know. It says the stock analyzer handler lambda function is experiencing errors due to missing API keys, which is exactly the error. I deleted that from the database, and so it wasn't available. It's going to give some additional suggestions on top of that. And this is a very narrow data set that has a kind of a manually triggered error. So the suggestions aren't super relevant here, but when we talk about implementing AWS best practices, this is where the investigation tool can really help you. It's going to give you recommendations on how you can make your lambdas more resilient, how you can handle throttling issues and scaling and all that good stuff. So this is a great tool, and it's not only useful for understanding maybe application errors or incidents, but also you can use it to look into performance issues. So maybe you have services that are having a lot of latency or slow response times. You can use the investigations tool to look into that as well. And so hopefully kind of with these tools coming along, you'll be able to save some time on investigations. The last thing I'll say before I pass it on to Josh about the investigation tool, as I was playing around with it, the more information it has, the more useful it's going to be. And so turning on things like X-ray traces and telemetry, that's really going to help it understand the structure of your applications and your kind of distributed services. Yeah, really cool stuff coming along in CloudWatch. All right, Josh, I'm going to pass it over to you to talk about, well, generative AI.
Thanks, Mike. I want to talk about generative AI. There was a lot of announcements around this, so it was hard to decide what I thought had the most business impact, but there was a couple that really stood out to me. So the first one is Bedrock model distillation. So in the past, when you trained a model, you had to choose a large model, then you would add your data to it, and then you would train it. And not only were you paying for your trained data in that model, you're paying for all the rest of that large model to run and process. So with AWS Bedrock model distillation, now what you can do is you can create a specific model with just your data without the larger data set or needing a full-blown GPT-4 with everything else. Instead, you can have a very specific model. So some of the business impacts of this are the models are more accurate for your needs. So if you are in a business such as financial services, maybe manufacturing, where you're using jargon, terms that aren't generic, things that are very specific to your niche, this can be a great tool. It's also cheaper to run inference on. So as users are asking that model questions, it's also very cheap. It's cheaper to run that. Some use cases, you can have chatbots. You can have it to summarize documentation. If you have images for your specific industry, you can train on those images and then have it recognize that. So things like, parts in manufacturing, you could train on a bunch of parts and have the smaller model decide if parts are broken or not. Text classification, again, very niche. If you have a niche industry, you can use a model that's very specific for that and train on your text. The other one that I found pretty interesting was this idea of Bedrock agent coordination. And what this allows you to do is to take all of these niche small models and coordinate them in a larger orchestration. So I can have agents work on multiple step tasks and each agent know about their own domain or their own area. Within the AWS console, it will show me too how those agents or where the work is spread when using those agents. Furthermore, I can call APIs to pull in information. So some of the business impacts of this are I can coordinate across agents for complex workflows. Again, I can use those smaller models that are very specific without running a bunch of large models that are going to cost a lot of money. Some examples are creating chatbots with data from different areas of your organization and pulling that together. In the past, we did things like used enterprise service buses to pull data. We would write a bunch of services that were tied together using different technology. What this allows you to do is, using a simple tool, you're able to train an agent and a overall and a bunch of small models to pull that data in. So a great example is, I'm a patient and I want to schedule an appointment. I can go and pull that patient's medical records. I can ask additional questions for the patient, fill that out in their medical record, and then I can notify the patient that the appointment's scheduled. So I'm able to build these complex workflows very nicely using visual tools and without a lot of in-depth model training. The other thing I wanted to talk about was some of the high availability items that Amazon released. The first one is this concept of Aurora Distributed SQL. And so what this is, Tim mentioned Aurora Serverless. This is Aurora Serverless. But now what you're able to do is you can have a primary and secondary region, and you can do writes in both those regions and be strongly consistent. So think of it as I have two instances of Aurora, one in US East 1, one in US West 2. Now I can have applications in those regions write to Aurora in each own region, and then the data is automatically kept in sync. So if there's a downtime, there's no switching the writers over to this other region. There's no loss of data. The data is instantly consistent. So this is great if you have an application that's mission critical. You can deploy it in multiple regions, have those applications talk to Aurora Serverless in their own region. And if a region goes down, your end users won't notice. Another interesting one is now DynamoDB is able to do the same thing. So in the past, Dynamo was not strongly consistent across regions. Now it is. So you're able to stand up a DynamoDB global table. You can have your application writing in region 1 and your application writing in region 2. And if one goes down, there's no impact to your business. You don't lose data, and it's strongly consistent across regions. I thought this was pretty cool. Amazon actually developed their own time chip in order to make this work, which actually syncs to satellites so that time data is consistent across all of their Dynamo instances and their Aurora instances. So they're able to seamlessly know which order those records need to be replayed in. Now I'm going to pass it over to Melissa to wrap up.
Okay, we do have a couple resources for you. We know we covered quite a bit here today, so if you're curious to dive in further, the keynote and several of the talks are out on YouTube. We also recommend a blog put out by AWS that highlights some of the top announcements. We'll be sure to share these links in the follow-up email we send out. As next steps, these AWS updates are full of opportunities for business. In order to really take advantage of them, there are a few foundational steps we recommend you take. First, make sure your AWS environment is in order. Take a look at your current setup and see if there are any areas where you can improve things like security, performance, or cost management. Getting this right will help everything run more smooth. Second, make sure your team is equipped with the right cloud skills. Whether it's migrating workloads or making the most of cloud technologies, ensuring your team has the confidence to handle it will set you up for success in the long run. And lastly, AI came up quite a bit today. Can you already demonstrate its value in your organization? Before diving into bigger, more costly AI initiatives, it's worth identifying real opportunities and proving the impact it can have. Again, these are just a few things you might want to explore next. We're always here to help. If you feel like if you're ready to tackle any of these right now, our team has a lot of experience and we'd be happy to help you sort through some of these. Thank you again for joining us. If you have any questions or want to chat further, please don't hesitate to reach out to any of the team. We do have their contact information listed in the deck. We're also available as a resource if there's any way we can help your team out when it comes to evaluating your AWS health, upskilling teams, or demonstrating the value of AI in your business. We will publish the recording and slides and get those shared out to you via email in the next few days. With that, thanks for joining us and have a great rest of your day.